Hi everyone, I'm going to go ahead and start with 5.3. It is the notes and the homework for graphing square root functions. I'm going to be going over examples 1 through 3, and then 4 and 5 are your homework that is due by the beginning of class tomorrow. All right, so let's go ahead and get started. On this one here, I'm going to be going over the steps in a couple of pieces, and then we're going to jump over just to doing some examples. So we are talking about graphing the radical function. So if I was graphing it would be called a radical or a square root function. So if I was graphing this, I am graphing the absolute value of x. Now the absolute value of x, if I took an absolute value of any number, it'll always come out, when it's a square root, it'll always come out positive. So given a graph, our parent function is going to start at 0, 0, and it'll only be positive numbers. It will never come out with a negative value. Now, not to say that we couldn't transform this so that it produces some negative values, but the parent function of it is going to always be positive. All right, so when we're looking at transformations, there's a couple pieces that we're going to be considering. First, we're going to consider A. We are going to consider the H value. And we are going to consider the K value. A is going to tell us whether there is a vertical stretch or shrink. So a vertical translation. A vertical stretch or shrink. Translation is going to be the K. The H value is going to identify if there is a horizontal translation. And the K value is going to identify if there is a vertical translation. All right, so let's go ahead and look at a couple pieces here. First, I am going to be looking at, I said translation, but I wrote stretch. So let me get rid of that. Vertical translation. The stretch is with the A value. Talking and writing isn't going to work for me well today. Okay, so on this one here, I'm going to first go over the steps that we have listed, talk about the values that are on this table, and then go over a couple of examples. So first one, when we are graphing a square root function, we need to find the x values of our table. In order to do that, we are going to start off by setting the radicand equal to 0, 1, 4, and 9. Now, the reasons that we pick these values 0, 1, 4, and 9 is because they are perfect square values. And they're going to help us at least with the graphing part, so we don't have to deal with any decimals right now. You still could use 2 and 3 and 4, 5, 6, 7. You could use any value for the x that is positive, but it can give you decimals. So let's stick with these ones today. Once we solve these values for the x's in our table, we're going to substitute it into the equation to find the y values. Then we are going to graph it and draw one arrow. Then we are going to state the domain, range, and behavior, and any transformations and positive or negative intervals. All right, let's go ahead and get started, though, with graphing the parent function. So the first thing I'm going to do is I'm going to take, how about a different color? Take this value, the radicand, and I am going to set that radicand. So here's the radicand, here, 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 and here. And I'm going to set the radicand equal to 0, 1, 4, and 9. Okay. The same numbers that I boxed up on the steps. Now, these ones here is x equals 0. Then I have x equals 1. Then I have x equals 4, and I have x equals 9. Now I'm going to go ahead and plug those into the original equation, which is this. So the first time I'm going to have f of 0. So I'm going to replace the 0 in the radical, or the x inside the radical with a 0. The square root of 0 is 0. So the output is 0. When I replace the x in the radicand with 1, the square root of 1 is 1. When I replace the radicand with 4, the square root of 4 is 2. And when I take that value into the radicand and I replace it with 9, the square root of 9 is 3. All right, I'm going to go ahead and graph these ones. So I have 0, 0, 1, 1, 4, 2, and 9, 3. Okay. So I'm going to go ahead and graph this. This graph starts out here, it starts increasing, it's still increasing, it's continuously increasing. So this one here will point just up ever so slightly because it is going to continue increasing as time goes on. So the domain is speaking of the x values. So when I'm looking at the x-axis, I'm looking at this here. I want to know how far this graph goes from left to right. Well, it starts at 0, 0. It has x is 1. It can have x is 2, x is 3, x is 4, 5, 6, 7, 8, 9, and it'll continue on. So the x values are constantly increasing, but they start with 0. So they go from 0 to positive infinity. And since we don't know positive infinity, we're going to put a parenthesis on that side. I mean, we know that we haven't got there just yet. It's a continuous number. And since we haven't come to the end of numbering in that direction, we just call it positive infinity. Now the range, on the other hand, is talking about the y values. So it's asking what's the lowest y value that it'll touch and what's the highest y value. So the lowest y value that this one will have is 0. It starts where y is 0. And the further it points to the right, the further it points up. So then the range goes up to positive infinity. Now, for the positive interval, we are talking about when is the graph positive. There's 2 ways that we could write this. The first thing, we can say that y is greater than or equal to 0, because it really is. At 0, 0, it's positive. 1, 1, it's positive. So we're just looking at all the different options. The other way we can write it is we can say that it is positive from 0 to positive infinity. Okay. Now this time I'm just talking about it being from 0 to positive infinity. On this one we can use both parentheses. Okay. The domain, it's important that we use a bracket if it stops there. As for a negative interval, there is none. These values on this graph is negative, never. So we're going to put none here. There is no negative interval. The end behavior, as x increases to positive infinity, so as x goes to the right, f of x, or the y value, is also going to positive infinity. Transformations on the parent function is there are none. Okay, that's the parent function for that reason. This is before any transformations. All right, so now we're going to go on to look at some with transformations. So before I go on to number 2, I want to go back and talk about this transformation table up on top. So these are all the different transformations that we can have. We can have a horizontal translation, which means the graph is going to shift left or right. This is something that we're going to be using in class. Okay? If you notice that it's -2 underneath the radical, then it's going to move 2 units to the right. If it is a positive number, x plus some number under the radical, then it's going to move units left. Okay? So it's just looking at that, paying attention to the value underneath the radical. We are also going to be using vertical translations. Vertical translations is adding or subtracting a number, but this time it's not under the radical. It's actually outside of the radical, after it. So is how it's normally written. If it's a +7, or a positive value, it's going to go up. If it's a negative value, it'll translate down. For reflections, there's 2 types of reflections. There is a reflection underneath the radical, and there is a reflection outside the radical. The one that we are going to be using in this class is a reflection outside the radical. So not to say that there isn't one in the radical, that's just not one that I'm going to be working with, okay? All right, at this time. So horizontal stretch and shrink. Notice that they are a value in front of the x under the radical. Again, at this time, I'm not going to be talking about horizontal stretches and shrinks. Vertical stretches and shrinks, these we will be talking about. Looking at the value in front of the radical, so the a value, the coefficient up here. If a is a number larger than 1, it is going to be a stretch. If a is a number between 0 and 1, it is going to be a shrink. Okay? All right, so I put stars by those on purpose because those are the pieces that I'm going to be using. All right? All right, so let's go on to number 2. So first thing we're going to do is we are going to take the radicand and we are going to set it equal to those 4 values that I talked about in the beginning. Set it equal to 0, set it equal to 1, 4, and 9. All right, now I'm going to go ahead and solve for x. So I'm going to add 3 to both sides. So that gives me x equals 3. Here, I'm going to add 3 to the other side. So 1 plus 3 gives me 4. Then I'm going to add 3 to this side, and that is going to give me x equals 7. And I'm going to add 3 to this side, and that's going to give me x equals 12. All right, once I have the x values, now I'm going to plug those back into the function. So I'm going to have g of 3. So that's going to give me 2 radical 3 minus 3, which gives me 2 radical 0. The square root of 0 is 0, and 0 times 2 is 0. So when we substituted 3 into the equation, my output was 0. All right, next I'm going to substitute 4 into the equation. So I will have 2, and then I will have 4 minus 3. This will give me 2 radical 1. The square root of 1 is 1 times 2 gives me 2. When we substituted in 4, I got out 2. All right, now let's go ahead and substitute in 7. So I have 2, and then 7 minus 3 gives me 2 radical 4. Square root of 4 is 2. 2 times 2 gives me 4. Right, and the last one, I'm going to substitute in 12. So I have 2. 12 minus 3 gives me 2 radical 9. 3 times 2 gives me 6. Okay. All right, so looking at those values there, now that I have a table, I can go ahead and graph that. I want to point something out here, though. I'm going to go ahead and note something here. Underneath the radical, I have the numbers 0, 1, 4, and 9. Those are the same numbers that I used up here. So if these 4 come out to be 0, 1, 4, and 9, then I know that I'm doing my math correctly on this part here. Okay, so if any of them came out incorrect, so for example, let's say that this one came out to 2 radical 7 instead of 9, then I should know to go back and look at my work here. Okay, all right, so anyway, let's go ahead and graph a table here. So I've got 3, 0. And I have 4, 2, 7, 4, and 12, 6, which will be right at the end of my paper. Now when I graph these, show that they're increasing, and keep in mind that there is one arrow. Okay, so the domain on this one, the x value starts at positive 3, and it goes to the right all the way to positive infinity. The range starts as low as 0 and goes all the way up to positive infinity. the positive interval. Where is this graph positive? It is positive between 0 and infinity, or you can write it as y is greater than or equal to 0. This one has no negative interval, so I'm going to go ahead and put none. The end behavior, as x goes to positive infinity, y is slowly but surely still increasing to positive infinity. Transformations. So I have this 2 right out front. Okay. So when I'm going to go back up and look on the table and see where I see a 2 in front of the radical. A number in front of the radical would be one of these two here. So 2 is a number larger than 1. So this is going to be a stretch by a factor of 2. So a vertical stretch by 2. All right, I also see that it has a negative 3. So I'm looking for a negative 3 under the radical. So I'm going to go back up to the chart up here. Negative 3 under the radical. This is just similar to this negative 2 under the radical. And that one would go 2 units to the right. Well, since mine is negative 3, it's going to go 3 units to the right. So it's going to be a horizontal translation or a horizontal shift. Three units right. Okay, let's go on and do our next example. So number 3, I have taken the radicand of x plus 6, and I am going to set it equal to 0, 1, 4, and 9. Okay, I'm going to subtract 6 from the opposite side. So 0 minus 6 gives me negative 6. Subtract 6 here. 1 minus 6 gives me negative 5. Subtract 6 here. And 4 minus 6 gives me negative 2. And subtract 6 here. Ooh, that one should have been a positive. So let me fix that really quickly. That should have been an x plus 6. So if I have 9 minus 6, that'll give me positive 3. Okay. All right, first time I'm going to plug in negative 6. Second time I'm going to plug in negative 5. Next time I'm going to substitute in negative 2. And the last time I'm going to substitute in 3. So I have negative 2. And then I have negative 6 plus 6. So I have negative 2 and radical 0. Square root of 0 is 0. 0 times negative 2 is 0. Here I have negative 2. Substitute in negative 5 plus 6. And that gives me negative 2 radical 1. Square root of 1 is 1 times negative 2 gives me negative 2. Then I have negative 2. And I have negative 2 plus 6. Negative 2 on the outside. Radical 4 on the inside. Square root of 4 is 2. 2 times negative 2 gives me negative 4. Last one, negative 2. Put in 3 for x plus 6 is negative 2 radical 9. The square root of 9 is 3. 3 times negative 2 gives me negative 6. All right, on this one, I'm going to go ahead and do the transformations first because I want to see if I can make sense of what's happening. So this negative here, looking for a negative in front of the radical is going to be this one here. So when I have that negative there, that's going to be a reflection in the x-axis. Okay, so let's go back there. So the negative is a reflection in the x-axis or over the x-axis. So then rather than opening above the x-axis, this time it's actually going to open below the x-axis. That's something that I should expect to see. The other thing I have is this 2 in front of the radical. So remember, when we have a number in front of the radical, it's going to be a vertical stretch or shrink. Since it's greater than 1, it's going to be a stretch. So it's going to be a vertical stretch by 2. Then I have a positive 6 underneath the radical. So if you went back up to the table, that positive 6 under the radical is similar to this one here, which means it's going to move to the left. Okay. So it is going to horizontal shift or horizontal translation, either word, left 6. Okay. All right, so when I graph this, it should be below the x-axis. It should be taller, or I should say, let's look at that one in a minute. But then the horizontal shift, it should move left 6. So negative 6, 0. So there's negative 6, 0. Negative 5, negative 2. Negative 2, negative 4. And 3, negative 6. Okay, so this one does look like it's stretched out, and it's also flipped over the x-axis. And if I could draw through the dots, it would have went through that dot. And it is reflected over the x-axis. So the domain on this one, domain is still the x values. It started at negative 6, and it goes to the right forever and ever, so that's to positive infinity. The range looks at the bottom first. This graph is going to continue to go down, and it's going to go down forever and ever. So the range is actually starting at negative infinity. When it actually reaches the highest point that it'll ever reach, that's right here. This y value is 0. So the range is from negative infinity to 0, and that's where it stops. Positive interval. On this one, there is none. Negative interval. There's 2 ways that you could write it. You can say it is negative from 0, from 0, it is a negative interval, talking about the y's, from 0 to negative infinity. And as x goes to positive infinity, y goes to negative infinity. Okay? All right, that is it for me on this one here. Oh, I'm sorry, on the negative interval. We also talked about we could write it as y is less than or equal to 0. Okay. So number 4 and number 5, those are going to be yours for your assignment. Make sure that you complete those and upload this to Canvas. Have a great night.